Spectrum redshift. Think different. 9. Since humans entered space, astronauts have sent back a large number of photos. People were surprised to see that the entire universe is not full of light as imagined, but dark. The Sun and the Earth are two bright spheres in the vast darkness. People then realize the universe is not filled with light, but cosmetic rays. Human eyes cannot receive these rays, so we only see the darkness. Lights from the Sun and the Earth are the interaction results of their surface gas molecules and atoms with the cosmetic rays. Analyzing the light spectra can help us understand the components of light. There are three types of analytical spectra. 1. Continuous spectrum. 2. Emission spectrum. 3. Absorption spectrum. 1. Continuous spectrum. The normal light spectrum shows a continuously change from short wavelength to long wavelength light. It means that the light being analyzed contains all wavelengths from short wavelength blue light to long wavelength red light. 2. Emission spectrum. When gas molecules in extreme hot state, the high orbit electrons will emit light to release energy and fall back to the lower orbits. The light emitted by the gas molecules makes the emission spectrum of the gas. Each peak in the emission spectrum corresponds to the energy gap between the higher orbit and the lower orbit of the gas molecules. 3. The absorption spectrum. When light passes through some gas molecules, some wavelengths light are absorbed by the gas electrons, and they jump from low energy orbits to high energy orbits. As a result, these wavelengths of light are missing in the light continuous spectrum, only showed as black lines. These black lines form the gas absorption spectrum. Each black line in the absorption spectrum corresponds to the wavelength of light absorbed by the gas electrons, and they correspond to the electron transition energy in the gas molecules. The image of different analyzing spectra. Left, the continuous spectrum of the light directly from the source. Middle, the emission spectrum of the light emitted from the hot gas. Right, the absorption spectrum of the light after passing through the hot gas. In general, for the same gas, the peaks in its emission spectrum correspond to the peaks in its absorption spectrum, indicating the electron transitions are easy to occur between these orbits of the gas molecules. These wavelengths light are absorbed by electrons in the absorption spectrum. Also, are released in the emission spectrum. The continuous spectrum of sunlight and the continuous spectrum of a distant star are very similar. It shows that the composition of both lights are basically the same. However, when expand the spectra, there are black gas absorption lines in both spectra. The number and distribution type of these black lines are the same in both spectra. Only all the black lines in the distant star spectrum shift to long wavelength direction compared to those in the solar spectrum. The gas absorption lines are redshifted in the distant star spectrum. Since the number and distribution type of the black lines in both spectra are the same, indicating that the two absorption spectra are of the same gas molecules, then, it has to explain why the gas absorption lines of the star are redshifted. There are two hypotheses to explain the redshift of gas absorption spectrum of the distant star. Hypothesis 1, the star is moving away from us. This explain is based on Doppler effect. When a train approaches the observer, its whistling gas compress the air around the observer, making gas molecules collide more frequently, generate higher tone sound. When the train moves away from the observer, its whistling gas squeeze the air molecule less frequently, generate the sound of lower tone. The above image explains light redshift as Doppler effect. When the light source approaching us, light frequency increases, wavelength decreases, like sound gets high tune. When the light source leaving us, the light frequency decreases, wavelength increases, like sound gets lower tune and light redshifts. However, the hypothesis is questionable. 1. From the theory of light as particles, light is composed of photons, the frequency is determined by the spin of photons. Whether a light source is approaching or leaving, the spin of photons will not be affected. Therefore, the light source movement will not change its light frequency. 2. From the wave theory of light, the explain is still questionable. Sound is generated by the collision between air molecules. In Doppler effect, the approaching train whistle airflow increases the air molecules' collision frequency and generates higher tone sound. The leaving train whistle airflow decreases the air molecules' collision and makes the whistle tone lower. The starlight and sunlight are generated by the interaction of radiation rays with gas molecules. The light frequency, wavelength, only relates to the energy gap between the electron transition orbits in the gas molecules. Not relates to the interaction frequencies between the radiation rays and gas molecules. Increasing the interaction will increase the light intensity, but will not change the light frequency/wavelength. Therefore, the light source moving will not cause the light frequency, wavelength change. The redshift lines in the starlight absorption spectrum cannot be explained by the star moving away from us. Hypothesis 2. After the discovery of the absorption line redshift in the starlight spectrum, there have been discovered some line blueshift too. In order to explain them, the hypothesis of gravitational redshift was proposed. Theorists believe that gravity forms a gravitational trap. When light passes through the gravitational trap, first is attracted by gravity and falls into the trap, loses its potential energy. According to E equals 1/2h square root square, light frequency square root decreases, wavelength increases, redshift occurs. When light passes through and climbs out of the trap, its potential energy and frequency increases, wavelength decreases, blueshift occurs. The spectral redshift and blueshift correspond to these two situations respectively. To proving the hypothesis requires complicated experiment settings and calculations. There has no very convincing evidence yet. There are also some doubts about the second hypothesis. The previous video proposed the hypothesis that gravity is an electromagnetic force and the gravitational field is an EM field. Since light is electromagnetic radiation, it has indeed affected EM fields or gravitational fields. In nature or laboratories, there are many examples of light being affected when passing through EM fields. For example, 1. In Faraday's experiment, the polarized light deflected its polarization plane after passing through a magnetic field. 2. When light passes through small holes or narrow slits, light diffraction occurs due to the influence of Earth EM field. When passing a lens, light is influenced by the EM field of lens atom lattice, refract by its frequencies. In the universe, when light passing by a white dwarf, it is influenced by the strong EM field and deflects its direction. On Earth, when the sun or moon is setting or rising near the horizon, their lights are influenced by the Earth's surface EM field and deflected directions. Thus create the illusion that the sun or moon are bigger than usual. All of the above phenomena are the EM field influencing on light. However, the influence is only on the light moving direction and path, not on the light frequencies. Therefore, whether gravity can change light frequency, it is still a question. Then, can light change its frequency? The answer is yes. In the lab, the indicators change color with pH of solutions. Because their molecule structures changed and the absorption light frequencies changed. The common indicators are phenolphthalein and litmus. Phenolphthalein shows colorless in acidic and neutral solutions and light red in alkaline solutions. When pH equals 0.8.3, the central carbon atom in the molecule links 4 atoms and presents a tetrahedral structure. The 3 benzene rings linked to it are of different planes. The carbon electron moving range is limited. The energy gap between the electron orbits is large, beyond the visible light energy. The solution is colorless and transparent. When pH equals 8.310, the central carbon atom links 3 atoms and becomes a planar triangular structure. The 2 benzene rings linked to it are on the same plane. The carbon electron active range expands, the energy gap between the electron orbits becomes smaller. Electron transition can happen by absorbing visible light. Then the solution appears pink. Litmus is another common indicator. In solution pH less than 4.5, the N atom links 3 atoms and presents a triangular pyramid structure. Its triangle bottom is a plane connect the naphthalene ring plane. Electron's active range is wide. The energy gap between the electron orbits is small, which corresponds to the red light frequency. In solution pH greater than 8.3, The N atom only links two atoms and should be a linear structure. But because it is linked to the large naphthalene ring, the straight line has to bend. This causes a large tension in structure. The energy gap between the electron orbits increases, which corresponds to the higher frequency of blue light. Both situations of phenolphthalein and litmus. The absorption light frequency wavelength change is due to their molecule configuration change. From the reason of indicators' color change, it can be inferred that the redshift of absorption lines in the distant star spectrum may be caused by the gas molecule structure change. Perhaps the star is enduring some tremendous change, which causes the gas molecule deformation and reduces the energy gap between its electron orbits, so its absorption lines have redshifted. The starlight redshift phenomenon occurs at the star surface, due to the environment change. Not happens during the starlight passing through the universe. The starlight shift phenomenon may serve as a method in the study of the star surface environment. Reference of images and literature. Thanks for watching. Goodbye. December 28, 2024.